wanted to, we could add some additional syntax to make it easier. We could say this. There's a couple different ways you could do this. Readability wise, it's easier to do sys out on multiple lines. Sometimes it's easier to do line breaks. Again, this just depends on your coding standards. Calculator application. F number, operation, right number. Number, a float number, or decimal value. Operation, any math operator. A value of plus, minus, divide, or multiply, and right number, and a float number or decimal. So just starting there, I have one other thing I have to do. So if we were to run this, instead of getting index out of bounds, we would actually get this message written out. Now, in order for me to test that, I do need to update one thing here. So we did rename the application from example 1. So we need to change this to be our calculator calculator. Need to name it the name of our class. So calculator application, new calculator application. We need to make our variable a little more readable. EX makes no sense. So we know we want to reference the methods in calculator application. So really, we should just call it calculator application, calculator application. So we know the method, or we know the class that we're calling. We know argument 0 and argument 2 are going to be left and right numbers. So we'll say left number, right number. Argument 1. So one of the things we can do is we can also do this. So we can pick in the values. We can say string operator. Be clear. So we'll take operator and we will set it equal to args1. So now, as we do our case statement, we do our switch on operator. So if operator is plus, minus, divide, or multiplication, we know what methods we need to call. So then we're going to call calculator application. And instead of method 1, we're going to do add two numbers together. And instead of arg0 and 1, we will do left number and right number. Now, the beauty of this is if you have named your application and your methods clearly, especially your parameters, if I were to just say, hey, I want to do, this is where the code completion comes in handy. So I can take calculator application, add two numbers, and it will automatically pull in the syntax from our methods. So we have the variable name left number and right number. So if we actually name things the same, name our local variables the same, everything translates together. Everything is readable. It flows. So we have this. So we have calculate application again. Dot. This is going to be subtraction. Calculator method. Dot divide. And then calculator method, or calculator application, sorry, multiply. And then last but not least, so not a valid operator. So let me maximize this for readability. So we'll come back through here. So we have our document description for the application. It's going to be a calculator application. It's going to have functions to simulate buttons on the calculator. Great. Application was written by me. Started today, version 1. Our application name. Our method names are very clear. So we simulate plus on a calculator, add two methods, return the results. Our description, add two numbers together. So we get two numbers, we add them together, and we return the results of those two numbers. Same for minus, divide, and multiply. Now, we'll get to the rules in a minute, but just follow me so far. So based on how we've renamed this, everything is readable. So even if we were to delete our Java docs, the code is pretty straightforward. It's pretty readable, pretty understandable. So if you come down here to the main method now, so even if we didn't have the Java doc here, just because we added this method here or this sys out, this is essentially that document. So if I try to run this as is, so now we get our application is going to accept three values, simulate two numbers and a math symbol being entered into a calculator. Command, calculate application, left number, operator, right number, and it tells you what needs to be passed in. Because we didn't, it threw the exception. Now, we can handle that exception by simply returning, adding a return here. Return system exit 0. Actually, just do system.exit 0. System.exit 0 exits the application cleanly. So now if we run this, we get our message and we don't get the exception. But what we need to say is unable to run command syntax. And you can name this however you want, but just you want to make it as descriptive as possible. So application is going to accept three values, simulate two numbers, unable to run command. Syntax should be calculate application, left operator, right number, and then here are our values. All right, so we have our method, we can run it. So if we actually get the right values, we should calculate the operations. All right, so to do that, we need to go into our run configuration and set up some arguments. So let's add 1 + 1. and run, we get 2.0. If we run again, 1 minus 1, we get 0. If we run again, one divided by 1, we get 1, and so on. So as you can see, we can now run the application. Now, to thoroughly test the application, we should add some unit testing or other test classes, essentially that simulate what I just did. But other than that, this is pretty much how we self-document our code. So now if I look out here, I can look at the outline. So I have my calculator application, I have my main, I have add two numbers, divide two numbers, multiply, subtract. If I were to, way I can build the Java docs. There we are, generate Java docs. Destination, yep. Docs, finish, yes to all. So it just generated the Java docs. So if I come out here, here's my documentation. So if I open with web browser, so we have our clean Java docs or whatever tool you use to generate docs. We have our package name, we have our project, so we have our class, calculator application, brief description, very clean, easy to understand. Go into the calculator application. So we calculate applications, have function to simulate buttons on a calculator. Since version author, here's our constructors. We have our methods, so main, our application is going to accept 3 values. Methods inherent from class. We have our constructor, and we have our methods. Oh, that's what I... examples. When you generate Java docs, you need to include go. There we go. So when you generate your Java docs, you can generate the ones for package, private, static, public, because I did not actually declare these as public. They were class or package level. So when I regenerate it, now we get our additional methods. So there's add two numbers, divide two numbers, multiply, and then here's our documentation. So to write readable code, you can, as you can see, basically it just means writing code in plain English or whatever language you're in. You basically take what the application or the program is supposed to do and break it down into its individual parts and then document it accordingly. Or write your methods, variable names, or even the calculations in such a way that if you just read the code, you understand what that particular piece of code is doing. Otherwise, if you start out with the initial example I had, it looks like spaghetti code, very hard to follow, not real easy to test. And as you saw, we really didn't even know what the application was doing just by trying to run it. So let's go back over to the slides. So does anyone have any questions?
Is this how developers, when they bring in a developer and they tell him like, hey, please clean up this code, is this what they'll be doing, like pretty much going through each and every method to see how can they make it simpler, maybe for the next developer or somebody?
Depending upon what they're actually asking them to do, yes. It could be twofold. One, clean up the code could mean that you have very complex methods where the functionality of the method or the program itself could be doing multiple things. So for instance, say instead of doing all the individual methods for add, divide, multiply, subtract, maybe I had a method that just said calculate numbers. And you passed in all three variables, float, string, float, but you really didn't know what functionality really happened inside that method. But inside that method, you basically had all of this complex calculation. So you had, oh, okay, so if it's left number, do this. If it's or plus, do this. Minus, do this. So like this could have, like all this code could have been in one method. So like instead of these system.outs where I call the method, all that functionality could be in one method or program. And a lot of times when you're asked to clean up code or refactor code, what you're doing is you're taking all these complex, basically pieces of code, which are actually smaller pieces of code, and you break them down into their smaller components like multiply, divide.